Toby Amelie, and I've been an engineer at Barnhart for about 4 years now, and today I'll be presenting on removing valves, pumps, and motors in tight confines. If you have any questions, please send those my way, and I will do my best to answer those at the end of the presentation, along with the panelists. So as far as our agenda goes, today we will begin by diving into a few aspects that make this work really painful. And then we will walk through 4 case studies highlighting efficient ways to remove and replace these components. And finally, we'll wrap up with a 40-second animation and a summary of some of the presentation highlights. So why valves, pumps, and motors? All 3 are vital components in almost every industrial plant. You know, motors power pumps, valves control the flow of prized substances throughout the facility, and not only that, but they have to be maintained. And unfortunately, as you all know, they don't last forever. So almost independent of weight, we hear time and time again how painful the removal and replacement of these vessels can be. One of the major reasons is limited space. So some components were designed to last the entire life cycle of the plant, and now that life cycle has been extended. You know, or components are being upgraded and not being replaced in like kind, or plant expansion has just occurred. You know, it could be a variety of things, and none of these things are really that uncommon. Another reason is that the component center of gravity may be offset. And, you know, maybe initially it was not, but valves can get clogged up over time, and then suddenly that weight can be disproportionately distributed. And this can really create, you know, pretty substantial stability concerns. Not to mention dealing with lift points. So in this picture, you can see 2 trunnions at rather strange locations relative to one another, which can create rigging, you know, really pretty complicated rigging. And let's say a motor goes down, and some of you get assigned to remove and replace that motor with minimal planning. And I applaud you guys for figuring that out, but it can be challenging. What is the travel path? Which rigging is sufficient? How will it be loaded? Are the floor beams suitable? Do we have an accurate weight of the existing motor? All things to be considered. Not only that, but it can require a lot of modifications to the site or piece, whether adding lift points, removing pipes, or opening up walls. And all of this takes time. The longer a plant is down, you know, obviously money's being lost. So to be clear, I know you have certain ways you've always done this kind of work. And honestly, it works. But today I want to present other ways that can lower human exposure, reduce schedule, and also minimize impact to your site. So next we're going to walk through a few case studies. And again, you've removed and replaced these components for years. And this won't apply to every case, but hopefully these case studies highlight how we have benefited our clients, and then also provide some insight on challenges that you may face in the future. In the first case study, we were removing and replacing a 5,200-pound butterfly valve. And as you can see, it's tucked under the mezzanine there, and there are other components in this picture kind of coming towards us in the page that would impede the valve from coming straight out. So what options do we have? Are we sure that this valve would geometrically fit out? And we quickly figured out that this would come down to fractions of an inch. So in this case, a laser scan was required to ensure that no dimension was missed. And also, quick shameless plug here, but we do have the ability to laser scan in-house now. So if that's a service you are interested in, please let us know. We took that scan and then started applying some different potential solutions. You know, can the valve be extracted from its current location? If so, what is the safest, most efficient way to remove the valve while minimizing site impact? And here, you know, we can take a 3D model, put it on 2D paper, and that can be a great communication tool for talking through and even developing a plan with a customer. And what we landed on was a custom single beam cantilever solution that gave us the ability to reach underneath that mezzanine while keeping our tail swing to a minimum. And to rig to the valve itself, we actually designed and fabricated a lifting device to connect through the butterfly valve's existing bolt holes, which you can see in the bottom right-hand corner there, while maintaining the ability to swivel that valve during the extraction process. And here's some job pictures. And I just want you to note the clearances there, not only above the cantilever beam, but also that rear column. Now, were there alternative ways to do this? Of course, but this allowed all other components to stay in place and saved multiple shifts of time. And then this showcases the valve being removed from the hatch. We could have tapped lifting points into the mezzanine, analyzed the structure itself, removed other components, but to eliminate shifts and minimize risk exposure of that crew, we came up with a better solution. Getting into case study 2, there was a series of 24,000-pound water pump motors that had to be removed and replaced. And these motors were tucked back into congested areas of the plant. In this case, we utilized existing overhead crane hooks to tail these vessels to horizontal. But out of respect for your time, I just want to focus on the transport aspect of this job. And there are the motors in blue. Historically, this has been done a couple of ways. Number 1, using Hillman rollers and C-channel, like you see in that bottom right-hand corner, or 2, laying down steel plate and utilizing air skates. Now, completely different picture shown than the motors we were discussing in this case study, but the point is, although both methods worked, there was an alternative. So setup time to lay down plate for air skates or just devising a clean plan to motivate Hillman rollers can be a struggle. But in this case, we used our positive connection pusher gripper slide system to really do 2 things. Number 1, control the load, and number 2, also minimize setup time. In fact, in this job, we utilized both our light slide, which is easy to maneuver by hand, and our 500-ton slide, which allowed us to span some voids along that travel path. Here's a couple pictures of the pump motors on our slide system. Once again, this light slide can be carried by hand, so it's quick to assemble and allows for the controlled movement through a tight door opening, as you can see here. It also kept the crew out of pinch points. Case study 3 showcases the removal and replacement of an 11,000-pound motor. The engineering drawing on the left is really a side view of the picture on the right. So I added some arrows to help you connect the dots. As you can see, the top arrow is connecting the duct to the duct, and then the roll-up door with a bottom arrow. The issue was the overhead crane did not have the ability to travel over the component that was being removed. It was actually through the roll-up door in the right-hand picture there. And then also you can see the bridge girders just barely at the top of the picture. So what are our options? Can we jack up the motor and slide it through the opening? Potentially. Is there a better way? We ended up utilizing the plant's overhead crane in combination with our mini-mocks to reach under the duct, through the wall, and to the motor. Could we have done it another way? Yes. But the time it would have taken to set up the shoring and equipment, not to mention the extra crew members required, it would have been extensive. And this was a good way to partner with the plant and their resources, specifically the overhead crane, to optimize the solution, ultimately saving significant time. Here's a picture of the job. And I just want to point out, an engineering solution can make this work look really easy. And in this case, it did alleviate a lot of pain. But as you can see in the bottom right-hand corner, we had just a fraction of an inch of clearance coming through the opening. So having a really dialed-in rigging plan was critical. And for our last case study, we had to remove and replace a 16,000-pound delta valve. At first glance, it's hard to even locate a delta valve because of all the obstructions and the way it's hemmed into place there. Here's a 3D concept showing that area. Removing the overhead derrick structure was not an option, so how could we remove and replace this valve efficiently? Maybe adding lift beams above, removing obstructions on one side, skating it over through a wall opening and building a platform. And we have done a variety of these things, with similar components over the years. But before dialing in our solution, we had to do some clearance checks, similar to those checks that we did, for case study 1 a few slides back. And we were hoping to find a way to upend this valve through the above structure and minimize modifications to the site, like adding those lifting beams or removing piping. With lots of planning, in conjunction with the plant team, we actually devised a solution to reach through a void in the derrick structure, upend and remove that valve using adjustable rigging. And as you can see, our MOX was just floating over top of that elevator shaft. And then here's proof of concept. So hopefully you're starting to catch a glimpse of some alternative ways to remove and replace these components. And these are components that have been used for decades, right? Notice the clearance in the left picture. The impact to site was minimized, significantly as a result of the solution. And on the right, we see a picture of our moving counterweight cantilever system after the extraction. This is a really short animation of one way we could efficiently remove and replace a pump in tight confines. And in this case, the pump weighed about 22,000 pounds, just for your reference. But the idea here is the video hopefully helps to highlight that the possibilities are really endless for removing these components. Animations look great, but this is the kind of stuff we have done. So here we've got a cantilever system on top of our custom turntable, on top of a self-propelled modular trailer, in real life. To summarize, a lot of you have removed and replaced these components for years, and so have we. But I think it's important to understand that there is alternative ways to remove and replace motors and valves. Using larger than necessary crews and doing things the same way they've always been done may not be the most ideal way to attack the problem going forward. So let's work together on coming up with innovative and effective solutions to reduce human exposure, shorten schedule, and lessen impact. Thanks so much for your time. If you want to submit any questions, my panelists and I will take a minute to answer a couple of those, and then we'll wrap up our time together.
Toby, one question from a guy. He says, it seems like these are pretty specific to valves, pumps, and motors. Do you see other applications with these?
That's a great question, Chet, and I think the short answer is absolutely. Those are just 3 common examples that were selected really on the basis of them being used in a variety of industrial plants. But this would definitely apply to other things as well.
We got a couple questions for you. One is they're asking about manipulating some of the rigging devices that appeared to be way up high. So you showed the picture of the chain fall coming off of the MOX, upending the delta valve, and the question was, how is that done? I think if I can take a stab at the answer, oftentimes we'll use pneumatic hoists or hydraulic hoists, and so we're able to run the hydraulic hoses down to the ground to potentially the same pump that we're using to operate other pieces of equipment. So we don't have to have an extra crane that would get men or personnel up to that area. We can actually do the manipulation from the ground. The other question is, can the cantilever beams you show be operated inside a closed building? I guess this individual's got concerns over exhaust fumes in their facility.
Yeah, to answer that question, it can be. It probably just depends on what side it is. We have to work through the details, but we definitely have operated, and actually a couple of those examples were operated inside of buildings.
Yeah, our MOX does have the ability to be connected directly to plant supplied voltage, and so as it stands now, it has a gas-powered generator that powers the electric motor, and so we can bypass the gas-powered generator and provide voltage directly from a plant supplied drop. So that's an option that we have.
Well, that is all we have today. If you have any other questions or comments, please feel free to email me directly at tomley@barnhartcrane.com. And with that, I hope you have a great rest of your day. Thank you.